What's up, kids? This is Mr. Carlson, C Squared Mathematics. We are on our very last lesson of Algebra 2.1. Doesn't it feel good? Does it feel satisfactory? Does it feel like you completed something? You should be definitely going out to eat tonight or watching a nice movie to celebrate so that you can say, you're done with Algebra 2.1, but now you just need to pass the class. So this is the last lesson, writing quadratic equations. The homework quiz, we're going to go through the homework quiz after the bell work, objective essential question, and then what is writing quadratic equations? What does that even look like? It's really just two parts, 3 parts really, and I'm going to just show you the very difficult way to solve these, and then I'm going to start showing the easier ways afterwards, okay? Let's go through these 2 questions for bell work first to get started. So pause the screen because I think I have extra room on here. I do. Okay, so pause the screen if you need to. So this one, consider the function. This is in standard form. And then I want to determine without graphing whether the function has a min or max. Okay. And then find the min or max value and then determine where it occurs. So this is basically like saying find the vertex. And then identify the function's domain and range. I'll probably go a little bit further and find the x-intercepts as well, just because I think it's helpful, to be honest. So I'll even probably do D, find the x-intercepts, because I think it is just helpful. Okay? All right, so I look at this function, and I notice that each term can be divisible by 3, which means I'm actually going to divide everything by 3, because I don't really need that. Or at least factor it out. So I'm probably going to factor it out. That'd probably be best, is just to take out a 3. And I'll do that eventually. Actually, you know what? Let's just do that right now. I don't want to do it eventually. I just want to do it right now. So let's just factor out that 3 here. Because I will use this to a little bit more in depth, especially with x-intercepts. So I'll probably be using these 2 equations interchangeably. So this is x squared and then minus 2x and then minus 3. Okay, so that's what it looks like. It's great to know that when you're going through x-intercepts, but when you want to determine whether or not it's a min or max value, you don't really need to do that. So for A, if I want to find the min or max value, I need to find my vertex. So the first thing is I want to use my formula, negative b all over 2a. This is the formula that I use to find the x-coordinate of my vertex when it is in standard form. Could I technically put this in vertex form by completing the square? Yes, I could. I just don't want to. So what's my b? I'm going to actually use this one instead of this one right here. I'm only going to be using that one for probably my d value, for my d part, x-intercepts. So for here, I'm just going to use negative 6. So negative times a negative 6, and then 2 all over 3, which is my a. So this equals 6 all over 6, which equals 1. So that means my vertex so far is 1 comma something. What is that something? Okay, so I need to find this, but what's that something? Well, I take 1 and I literally just plug it in. So I plug it into my formula. So f of 1 equals, so this is 3 times 1 squared minus 6 times 1 minus 9. This equals 3 minus 6 minus 9. This equals negative 3 minus 9, which equals negative 12. So that means this is my y-coordinate. And so this negative 12 right here goes right here into my vertex. So this is my vertex. Okay? Sweet. Now I want to know whether or not it's a min or max. So I want to discover that it is a min. The reason why it's a min is because this is a positive 3 and not a negative. So that means it's going to go up. Remember our little smiley face? If it's a positive, it goes up. And if it's a negative, it goes down. All right, so that's helpful. So it's a positive, that means it goes up. So it is a min of negative 12, a min of negative 12 at x equals 1. So this is probably the formal way to put it, and this is probably what Math Excel is more than likely looking at. That's a formal way. It's a min at negative 12, y equals negative 12 at x equals 1. Okay? So my B, well, when they say find the min or max, well, it is a min. It's not a max. And where it occurs, well, that's just my vertex. So I'm actually just going to copy it down. But this is where it occurs. Okay, just that. C, my domain. What is my domain without graphing? Of course, it's just going to be negative infinity to positive infinity. Another way to write this is in set notation, which is the set of all x such that x, and getting really, really fancy with my math symbols here, is in the all real number system. So that's like a fancy way to do set notation, but you only really need to know the domain interval notation. My range. So that's going to be negative 12. I'm going to start there because it's a min, so it has to start at my vertex because it goes up. So I'm not looking at this one. It goes up. So that right there is like my negative 12. And then it goes all the way up to positive infinity. This is my range. If I wanted to put it in set notation, it would be the set of all y, not x, but all y, such that y is greater than or equal to negative 12. Okay, that's my C. And now my D values, just for fun. If I want to actually solve for this for the x-intercepts, what I do is I'm going to use this. So that's equals, and then this is 3. And then I'm going to factor this out. Before I factor it out, I'm going to actually divide by 3. So this is 0 equals. And then I'm going to factor this puppy out. So that's going to be factors of negative 3 that somehow, some way add up to negative 2. That's negative 3. And then x minus 1. So that means x equals 3 and then 1. Boom. Okay. If I wanted to go even further to find my y-intercepts, I absolutely could. Just plug in 0, f of 0. So just plug in 0 for x. That goes poofy, that goes poofy. And you get negative 9. So that means y equals negative 9. That is going to be your y-intercept. All right. So this is basically how to get all the properties of your quadratic graph without even graphing it, which is pretty cool. I could even find my axis of symmetry. My axis of symmetry is just x equals 1. And so that's my axis of symmetry. I'm just going to use my vertex form there, my vertex point. All right, I don't want to spend any more time on this question, so let's move on. But that's essentially how you do it without graphing. I didn't graph it at all. Now here I will be graphing, okay? I could do the substitution method. I don't want to take up any more of the time, so I'm just going to graph it for you. So let's go to Desmos to graph it. Let's see where these points lie, okay? I'm going to just graph it here. I'm actually going to turn this stuff off. Let's graph this. The first one I had was x plus y equals 2. And then the next one I had was y equals x squared and minus 6x and then plus 8. So this is where the two graphs lie. I'm going to zoom up a little bit. And so where do they intersect? They intersect there and there. So what are my solutions? 2, 0, and 3, negative 1. Those are my solutions. And I would put those into Math Excel free of charge. Thanks, Desmos. So, of course, yes, you can solve this by just substitution. I would substitute this whole thing. I would take that and substitute it right there, simplify it, subtract the 2 over, factor, and then start plugging and chug. But I don't want to do that here because I just don't want to waste the time. All right? Fantastic. Let's move on to the homework quiz. So 5 questions, 25 minutes, of course, open notes. Please review your answers and then get started. Review after you review your answers, get started on your last lesson of Algebra 2.1. So how can I write quadratic equations? How can I write a quadratic equations? How can I really model it and analyze the graph, the points that they give me so I can write it? So I'm going to go through a very, very difficult example at the beginning, and then the rest of the examples are going to be very, very straightforward. Okay, I'm going to introduce a new Desmos. Calculator for you so that you can utilize that and you can use it on your test quiz Homework quiz. Okay. So writing quadratic equations, we're going to first start out with what if I'm just given the points? So if I'm given the points of a quadratic equation, how can I get that equation back? If I'm just given the points, saying that these points lie on the quadratic graph, how can I use those points to then come up with in the actual equation? So now we're kind of working backwards, as you can tell. We're no longer looking at the equation and then getting a graph. We're given a graph or points, and then we want the equation. Okay, so it's a little bit more tricky. The first thing is first, given any 3 points, you're going to solve it like this using these steps. Okay, given any 3 points, you're going to solve it like this. The second step is substitute those points, into the general form equation and then simplify. I'm going to show you what that is. And then here's the hard part. You're probably going to crap your little pants here. You're going to solve the 3x3 linear system. Oh, the horror. We hated 3x3 linear systems. Yes, we hated them. And now you have to solve it again. So unfortunately, that is the case. After that, the fourth step, probably the most important step, substitute those solutions back for A, B, and C into the general form equation. So I'm going to be given this. I am going to be taking this one pretty slow. I am going to solve the whole thing out, the 3x3 out, because I think it's necessary to show you. And then after that, I'm not going to do the 3x3 anymore. I'm going to give another example. I'm going to show you how to set up the 3x3, but I will not show you how to actually solve it using the 3x3. I'm going to use a calculator from there. Sounds good? Okay. So how do I solve this? Well, the key thing is to know that this is my general standard form of the quadratic equation. I'm actually going to rewrite it like this: ax squared plus bx plus c equals y. That's how I'm going to necessarily rewrite it. So I'm going to be using that form, but it's literally the exact same thing. Now I'm given these 3 points, and you do technically need 3 points. In order to solve these types of questions, you more than likely do need 3 points. With the linear equation, you needed 2 points. With the quadratic equation, you needed 3 points. You get the picture. With a cubic function, you would probably need 4 points, and so forth. All right. So I have these 3 points. Now I'm going to label them as 1, 2, and 3. Now watch. I'm going to label this as 1. I'm going to use this point, -2, -3. I have in my actual quadratic equation x and y. Well, that's interesting. I'm given an x and a y. So I'm actually going to take -2 and plug it in for my x's here. And I'm going to take -3 and plug it in for my y. Now watch what happens. This is going to be a times -2 squared plus b times -2. Can't do anything for c here, equals, and then my y is -3. When I simplify this, watch what happens. This is still my first equation here. I have -2 squared is 4, so 4a minus 2b, and then plus c equals -3. You see what I did there? I basically eradicated the x and y's, and I got a, b, and c back. Well, that's 3 variables, which means I have to have 3 equations. So let's do it for the second one. I do the exact same thing. Plug now 1 in for x times 1, and then plus c equals, and then -6 for y. So I'm going to get my new equation back out. This is just a squared. That's nice. And then plus b, and then plus c equals -6. And then let's do the third one. So I'm going to take -3 and square that, plus b times -3 plus c equals -6. And then this is my third equation. So -3 squared is 9, so this is 9a, and then minus 3b, and then plus c equals -6. Sorry, not -6, -18. Let me erase that. Almost made an oopsie there. -18. Perfect. Okay. Now I'm going to take these three, and this is the hard part. I'm going to take those three, and I'm going to perform the 3 by 3 linear system on it. Okay, so you could do a couple things. Actually, this is not squared. Another oopsie. Sorry, 1 squared is just a. So you could take all this and you could perform a couple of different operations. I don't think there's any bonus that you could do here. But what I could do is, I guess, eliminate 2 and 3. You can eliminate 1 and 2 first. I'm going to eliminate actually 2 and 3. But I'm going to do that by multiplying this by 3. So my new second equation is 3a, and then plus 3b plus 3c equals negative 18. And then my third equation is literally the exact same thing. 9a minus 3b, and then plus c equals negative 18. So when I add these together, of course, this becomes 12a, and this goes poofy. This becomes plus 4c equals, and this is negative 36. Now, I can't do anything here, which means I have to do 2 other equations to combine 2 other equations so that I can eliminate the exact same variable. And this is great. You know why? Because I can definitely do that with equations 1 and 2. So that's what I'm going to do. My new first equation, I'm not going to do anything with that first equation. And I'll tell you in a little bit why I don't do anything with that equation. So I'm going to keep this chilling because I can't do anything more with it, right? And so my new second equation is I'm going to multiply this by 2. I'm going to multiply that by 2. So 2a plus 2b plus 2c equals negative 12. Okay? Perfect. Perfect, perfect. Awesome. Let's combine these. Let's add them. That goes poofy. This now becomes just 6a. This becomes plus 3c, and this becomes negative 15. Now what I'm going to do is combine it with this. So now notice I have just a's and I just have c's. So I'm going to perform this 2 by 2 to solve it. Man, this is really something. How can I do that? Well, I can multiply this by negative 2, right? I can multiply that by negative 2. So I'm going to do this all in one sweep. So follow along. Negative 2, those go poofy, of course. Negative 2 times 3 is negative 6, so this will become negative 2c. Okay? And then negative 2 times negative 30, or is negative 15 is 30, not negative. Negative 2 times negative 15 is 30, and then this is just going to be minus 6. Okay? So again, this right here times that, 30, negative 36 plus 30 is going to be negative 6. I divide, so that means c equals 3. Perfect. So I got my c value. Now I need to plug it back in. I'm going to just plug it back in for here. So let's just find my a. So 6a plus 3 times 3 equals negative 15. This is 6a, and then this is equals negative 15 minus 9. And so 6a equals negative 24. And so that means a equals negative 4. Okay? Perfect. All right. So now I got A, I got C. So let's now find my B value. Okay, I'm going to just probably plug it into one of the original, which is probably this one because that's the easiest one. So let's go over here and plug it in. My A is negative 4 plus B plus my C is 3 equals negative 6. These combined would be negative 1. And then when I add it over here, I would get B equals, and then just negative 5. Perfect. So I have A, B, and C. Now, what is my final answer? My final answer is going to be literally to plug those values in for A, B, and C. So that would be my final answer. So I'm going to kind of erase my A, B, and C values there and plug it in. Okay. So my A, what was that? Negative 4 and then x squared. My B was negative 5. And then my C was 3. This right here is my final answer above. Negative 4x squared minus 5x plus 3 equals y. A lot of hard work, right? A lot of really tiring. Like, who wants to do that? That sucks, okay? And of course that sucks. So I'm going to show you now on the next slide how, actually, you know what? I'm going to just show you now what we can do, like a simple thing on Desmos where we can plug it in and we would get the exact same answers. Okay? Awesome. So let's take these points actually. Let's take these points and we're going to use these points on Desmos to find what the actual equation of this quadratic is. Ready? So what you're going to do is you're going to go over here to Desmos and it's going to be called, I don't even know what it's called. Right here. Perfect. It's being called this. Okay. It's called the writing quadratic functions given 3 points. Where is it found? It's found on Google Classroom. So if you go to Google Classroom, go to classwork, and it's going to be in Unit 3 right underneath your graphing quadratic videos, right before your writing quadratic functions videos. So let me go all the way down. Wow. Are you serious? Wow. Oh my gosh. This is freaking ridiculous. This is my drive. That's not my drive. This is my drive. That was my personal drive. Are you serious? I can't believe this is actually happening. Okay. Classwork page. Go down to Unit 3. It's going to be right here, Writing Quadratic Equations, Desmos link. All you have to do is click on that. It'll come up on Monday, 8 a.m. Okay? Click on that, and then you can save it to your account. That's where it's at. So Unit 3, down here at Classwork page, scroll down here, right underneath the Writing Quadratic videos. You're going to do that. Okay? Perfect. So this is what you have. Now, all you need to do, literally all you need to do is just type in your points. So my first point was -2, and then I want to scroll over here and then do -3. Now you'll start to see these points kind of change a little bit, right? My second point was 1 and then -6. Okay. My third point was -3 and then -18. Perfect. Perfect. What we got was A is -4, B is -5, and C is 3. That's what we got, right? -4, -5, 3. -4 for A, -5 for B, and then 3. Pretty cool, right? And this is your graph. So what does that mean? That means you still need to plug that in. You still need to say y equals -4x squared, and then minus 5x, and then plus 3. You still need to say that. You still need to kind of put these 3 parameters, those variables together into your standard form of your quadratic. That's still something you need to do. However, this is awesome because now what you can do is not only see the graph, but you also get the points. You get the points on the graph. It's very, very cool. Very cool. Okay? And that is the only quadratic that is possible with those 3 points. What I utilize here is something that you'll learn in statistics. If you take stats with me, which I highly encourage you to take stats with me because it's very fun and it's Desmosified. Like, you use Desmos all the time and it's a really fun class. very applicable. And this is what we call the regression line. It's called a regression line. It's one way to solve these problems. Another way to solve it is using what we call a matrix. And that's something that you'll learn in pre-calculus if you take pre-calc with me. So all these different ways to solve it, you can use a 3x3, you can use what we call regression line, just basically changing your values, your x and y values, pretty cool, on Desmos, or what we call a matrix, something that you won't learn until pre-calculus, okay? All those different ways that you can utilize in order to solve a 3x3 linear system. So you don't need to do any of this. So let's erase and let's go through our next example. The steps will be the exact same, but hey, we're not going to do that. We're just going to go straight to Desmos. The only part, though, that's different about this question is that they're not necessarily given in easy points. But if we recognize that this is x, that is y, this is x, and that is y, then we can easily follow through with these points. What is this point? Actually, let me just erase that, and let's just do this instead. What is this point? This point right here is 1, 3. This point right here is -3, 43. This point right here is 3, 7. So with those 3 points, we're now going to take those, because that's all really the setup that we need. We just need those 3 points. After those 3 points, we're going to take those and plug it into Desmos into what we call my regression. Okay? I could solve these steps. If you want to do that, absolutely go for it. You don't feel obliged to do it. If you want to practice your 3x3s, I'm not going to. So let's go to Desmos. Okay. Make sure you get these points down. I'm going to plug them in right here. So these points, my first one was 1, and then I'm going to scroll over and just type in 3. Okay. My second point was -3. I'm going to scroll over and just type in 43. Okay. You'll start to see it kind of mess around, right? Next point, I have 3. My final y value is 7. And so now what I can do is actually zoom up. I can click that zoom fit, and then it'll actually give me my quadratic right here. I can zoom out if I really want to, but this is my quadratic. Pretty cool, right? I think it's pretty cool. So this is your quadratic right here. So those are your points. These are my quadratics, but these are your parameters, your A, B, and C value. So if I'm given y equals ax squared plus bx plus c, this is my general formula. Now, since I have these values, 2 is A, my B is -6, and my C is +7. This is my final answer. Perfect. Perfect, perfect. So let's continue with this line of thinking, but we're no longer going to be using Desmos. I'm probably going to be using Desmos once more in 2 examples from now. But I hope this helps. I hope you don't necessarily need to just drag your brain into the ground with the 3x3s. I hope this is very beneficial to you. Okay, so I'm going to erase this. If you have any questions on this calculator, by all means, just let me know. If you accidentally exit out of this and you're like, oh shoot, what do I do? All you have to do is just click on this, it's undo, and it'll undo it for you, okay? Same thing here. If you're like, oh shoot, what do I do? Just click on this, it'll undo it for you. If you accidentally like erased a plus sign or something like, oh shoot, what do I do? Just click on the undo button, okay? All this other statistics and the residual stuff, that's nonsense. You don't need to know that for algebra. That's something we learn in stats, but it's not something you need to know in algebra. You just need to know those points. By the way, if you graph this, you also have the vertex. Ha! All right. By the way, this equation is imaginary. It doesn't cross the x-axis. Just wanted to let you know. It's imaginary. It doesn't cross the x-axis. Let's go to this example, all right? So what if I'm given a graph? What if I'm not given any points at all? So if I'm just given a graph, what do I do? So the first step is use the vertex form, okay? Find the vertex and then determine the A, the pattern, like what's the A value, and then plug everything in together. So I'm going to show you what that is right now. So what do I do? Well, I want to find the vertex. The vertex is always going to be the min or the max. So in this case, it's going to be right here. What is that point? This point is 4, comma 4. So this is my vertex. Okay? Perfect. Now, another thing I want to do in order to solve it this way, I want to find a different point. I should have probably put that in the steps, but I'm sorry. I want to find a different point, just any other point. But I want to find an easy point to use. So I'm going to actually just use this point right here because that point is very, very easy. It definitely crosses that. So what is that point? That point right here is 3, comma 5. Okay? So how do I set this up? I have a vertex and I have a point. I have a vertex and then I have a point. Let's use both of them. I'm going to be using y equals a x minus h squared plus k. Just like this, it's the exact same formula. I'm just tagging on a y. Now, watch what I'm about to do here. I have a vertex. This vertex is h and then k. I have a point. This point is x and y. I want to find the a, so I just plug in x, y. I also plug in h and k, and then I can find this a value. So I can find what that pattern is, the only unknown. So what is my y? My y is 5. Notice how I labeled that there? So it's going to be 5 equals. I don't know what a is. What's my x? I also labeled that as 3. So I'm going to put that as 3 minus my h. My h is 4 squared. And then what is my k? My k is also 4. Okay, so I'm going to be plus 4. So when I start solving this, notice how my a is my only unknown. So this is a very, very cool trick to basically use your vertex form. As long as you have your vertex, if you're given a graph, and you can find your vertex, and then you also can find a different point, this is a great way to solve for your quadratic equation, okay? Your quadratic equation, your actual quadratic. So how do I simplify this? Well, 3 minus 4 in parentheses, that's just -1. I square that plus 4. -1 squared is just 1, and then times a is just a. So I am given this. I subtract the 4 over, so that means a equals 1. What does that mean? That means if I'm given a vertex and a is equals 1, that means this is my actual equation. Y equals a, which is just 1, but I'm not going to write that, right, because it's just 1. X minus my h, which is 4, squared, and then plus 4. This is my actual equation. Okay? And it's that simple. And if a was 3, then you would just plug in 3 right here, and then like right in front, and then you would just follow along with your vertex. If a was 5 or -5, then you would just plug 5 or -5 there, follow along with your vertex. Simple as that. Okay? Now, this is all great and well. Most of the time, though, Math Excel is going to be amazing and actually give you A, B, C, or D. They'll actually share with you A, B, C, or D and say, okay, which one is it? So most of the time, you won't necessarily need to do all that math. You'll just have to select a multiple choice answer, which is always fun. But I did want to show you that math just in case. So clearly, which one is it? X minus 4 squared, quantity squared plus 4. It's got to be D. Okay? It's definitely D. Awesome. Great. So let's erase that and let's go through another one given a graph. So that's when I was given a graph, but the vertex was easily found. What if I can't easily find the vertex? What if I still want to put it in vertex form, but I can't really find the vertex? That's a problem. And another big problem is sometimes Math Excel wants you to put it in a vertex form, but you can't easily find the vertex. So that sucks. What do you do then, essentially? So a way to do this is, first of all, follow the steps. If you can't find the vertex, you want to try to find the vertex, but if you can't necessarily find the vertex, if that does not work, then you would have to go back onto your original steps, find 3 points on the graph, and then solve the 3 by 3 linear system. I'm not going to solve the 3 by 3 linear system. I'm going to be using Desmos, okay? But by all means, you can solve the 3 by 3 linear system if you wanted to by using the same steps as we did before on our very, very first example. So let's find 3 points on the graph here. Well, I find one right here. That point appears to be 3 comma negative 6. I find 1 point right here. That appears to be 4 comma negative 6. Okay. And then let's just choose this one down here. So this point is 2 comma negative 8. All right. Let's just choose those. So I'm going to take those and I'm going to go to Desmos and start plugging it in. Shall we? Awesome. Make sure you have those points down. I have those 3 points. Let's go to Desmos, plug them in. So my first point we said was 3 negative 6. So I'm going to type in 3 and then negative 6. My next point was 4 and then negative 6. And then my last point we said was just going to be 2 and then negative 8. Okay? And this is my equation. This is what I have, which is pretty cool. Now, it's really hard to find the vertex. That's the vertex here. So once you have the equation, you can then write the vertex. That's the amazing part. Once you have the graph on Desmos, you can do the vertex. The problem with this is you really can't find the vertex here. I mean, what is that, 3.5? I mean, it looks, well, obviously it is 3.5, but you don't know and you don't want to eyeball it from Math Excel, right? Because this is something that you'll get from Math Excel. What you want to do is go to Desmos, type in the regression, you have this, and now you can clearly find what the vertex is from Desmos. But first, what is my equation in standard form? My equation in standard form using these parameters is negative x squared, because that's my a. My b is 7, so plus 7x, and my c is negative 18. So this is what it is in standard form. Okay, standard form. Now, if I want vertex form, all I have to do, I could complete the square on this, right? I could, but if I have Desmos, then I don't necessarily need to. I can go faster. So if Math Excel wants the vertex form instead of the standard form here, what I can do is just take those. So I have 3.5 and negative 5.75. So that means I have y equals, I'm actually going to write this vertex down. So 3.5 and negative 5.75. So that's my vertex. It's something right here. Actually, let's just do this. This is way easier. Let's just make a point. So this is going to be 3.5 and then negative 5.75. Let's make that a point, and then let's just label it. That'll be way better. But I definitely don't want it to be green. Let's label it just black. Or orange. Nah, let's label it black. Okay, great. So that's going to be my point right there. And great, awesome. So let's put that in vertex form. So my a is actually a negative 1. So I'm actually just going to put the negative there. But this is going to be x and then minus 3.5. And then this is going to be squared and then minus 5.75. Even if you wanted it in fractions, you could, which is awesome. Remember, you can go over here and just type in 3.5 and then negative 5.75. So even if you wanted it in fractions, you can put it as a fraction, such as this. And then you can even make that as your actual formula. So minus, and then this is x minus 7/2, and then square that, and then minus 23 all over 4. So this is the actual equation in vertex form with fractions. Notice how amazing Desmos is. It basically just makes math easier. It just makes math easier, so you're not using all your mental capacities to try to figure it out. It allows you to switch between fractions and decimals. It allows you to find your vertex. It allows you to find the equation. It's amazing. Okay, so that's my equation. That's my answer. Both of these, actually, depending on what form they want. So that's the last time I'm going to use Desmos here. Last time I'm going to use Desmos in the class. Isn't that sad? As a lesson, at least. So let's erase. And I'm just going to erase all this junk because I don't actually need that. But feel free, guys, to just use this. This is an amazing thing. Definitely feel free to use that as much as possible. Awesome. Let's move on. So what if I'm given the vertex? So we found so far, if I'm given points, I can use Desmos, the regression calculator. If I'm given a graph, I can use the vertex form to find those, but that's only if I can find the vertex easily. And if I'm given a graph, I can't find the vertex easily. I just find 3 points and use Desmos. Now, what if I'm given a vertex? So write an equation with a parabola that has the same shape as the graph of f of x equals 3x squared, and then this point. Now, in this case, I don't actually need to use Desmos at all. I just want this same shape. So honestly, guys, all I have to do is this. F of x equals 3, and then I'm going to implant my vertex in. So that means plus 3. Notice I did the opposite sign here because there's a built-in negative inside my vertex form. If this is a negative h value or negative x coordinate for my vertex, I need to implant that for plus 3. Or I need to plant that negative 3, so the negative times the negative gives me a plus 3. And then this is going to be a plus 4. This is my final answer. Very simple. Not too many steps involved, right? Let's try this one on your own. So pause the screen real quick, pause it, see if you can get this one on your own. It's the same shape as 9x squared with this vertex. Try it yourself. Perfect, that's what you should get. If you don't get that, then go back over your work, but this is what you should have. This is 9x squared, so I make sure I have to have the 9 in there, and then the 6 and the 2. Remember there's a built-in negative, remember that, and so it's 6 and then plus 2. Sweet, let's move on to our very last slide of Algebra 2.1, our very last slide. Write quadratic equations. Now, not given a vertex, not given a graph, not given points, but given a max or min. So, it's basically almost exactly how it was in the previous slide, but just a little bit different. Write an equation in the parabola that has the same shape as this or this. Now, it's dependent upon if it's a max or a min. If it's a positive here, that means that's going to be a min. Okay? If it's a negative, that means it's going to be a max. Now, since it wants a maximum equals 7, what that means is it's not going to be a minimum here. Okay? I'm going to be utilizing the negative 9. I'm not going to be utilizing this. So what is this actually saying? If it says a maximum of equals 7, maximum equals 7, what this is saying is my y equals 7. That's what it's saying, where of course my x equals negative 8, which means this is my vertex. So my vertex is negative 8, 7. So since I know that now, I can finally use that information to put into my vertex form. So using the same shape, negative 9, because it's a max, so negative 9, and then using my vertex, it's going to be x, and then plus 8, because there's a built-in negative, do the opposite for the x value for my h, and then plus 7. This is my final answer. Notice how if I graph this, it would be something like this, where you have negative 8 and then, negative 8 and then 7. So it's actually going to be over here. So negative 8 and 7. So it looks something like this, just briefly. And of course, that is my max. Okay, so I can deduce that from my vertex. Let's go to our last equation, our last question here. Let's do it in red. So again, it's going to give me this 4x or this. I want to know which one it is. This is my min, and this is my max. So if it's asking for a min, I don't want that. Now remember, this is the same thing as saying y equals 0, where x equals 4, which is the exact same thing as saying my vertex is going to be 4, 0. So since I know that, finally, I can write my equation. I'm going to use 4 because it's a min, and we want a min. So 4, and this is going to be x minus 4 because there's a built-in negative squared. And then actually, technically, it's just plus 0, but do we even really need to write that? No, we don't need to write that at all. So we don't need to include that plus 0 there at all. That's my final answer. That was the last equation, the last lesson, the last example of Algebra 2.1. So I hope you guys enjoyed the class. It's primary. I'm going to have one short lesson tomorrow going over the video or going over like bell work, but it'll probably be like 5-10 minutes, and that's it. All the rest of the days will just be review for your test, your quadratics test, and then also review for your final exam. So let's erase this. Summary, what did we learn? We learned how to write a quadratic function given 3 points, given a graph, given a vertex maximum and or minimum values. And then as well, just basically determining a quadratic function's minimum or maximum value. Okay? Retakes are still available. Make sure you email me if you want to retake the Solve Quadratics quiz. But until next time, guys, this is C Squared Mathematics. I'm Mr. Carlson. Make good choices.